Hey there, and welcome to our tutorial here on social Excel for social workers. And this one, we're going to focus on the t-test and the Anova, which are two statistical tools that often come up when doing analysis of program or services data. And the key to these two is that the t-test is used when you want to compare some type of continuous or numerical outcome indicator at two time points in the paired samples t-test. And so what we have is a pre and a post score here. So what we want to do is see, is the difference in the mean at the pre and the post score. That's what we're looking at with the t-test. And with the Anova, what you're going to do is you're actually comparing three groups on one particular outcome indicator. That's the single factor Anova that we'll work on a little bit together. Now, let's start with the t-test. Now, we have already shown here that the pre-score for our average pre-score using the average formula in Excel, which is a great one, shows that the pre-score was 4.65 and the post-score was 6.675. And so it looks like they're different, but what we want to do is say, is that difference something that kind of maybe just occurred due to chance? Or is that something where we believe that there's a statistically significant difference between those two means? In hypothesis language, what we're testing is the difference between those means zero or not? That's what we're testing statistically. But I don't want to get you bogged down in jargon and statistical stuff. You can go take a stats class if you want to do that. What I want to do is show you a couple of quick Excel formulas and tools that you can use to help you make good judgments in the data without being an amazing statistician. All right. So what I'm going to do here, well, you should be an amazing statistician. That would be a good thing. All right. So coming back over here to our pre and our post score, what we're going to do is we're going to go first, we're going to click on the data ribbon up here, and then we're going to click where it says data analysis. Okay. And then we're going to click on where it says t-test paired two samples for means. Now there's different t-tests you can do here, but we're doing the paired two sample testing for means. That's what we do when you're doing a pre and post test, when you've got the people who have the same data or the same people were tested at the pre and the post. Okay, so I'm going to click OK here. And then what I have to do is I have to select the data. It looks like it's already done it for me here, but I'm going to go click on the G and I'm going to scroll down from G1 to G41 so I can get that in, press return. Voila, that's my variable 1 range, my variable 2 range. I will click and highlight H1 to H41. Voila, click return. A hypothesized mean difference, what we're testing is the difference between these two things zero or not? Right, that's what we're testing, right? So we're going to leave it at 0. Click on labels here because that just shows that your G1s and H1s aren't going to be included. Alpha 0.05, leave that there. The output range is just saying where is the output going to go, and that's going to be right here on L4. You can go ahead and select that. It can really be any of these ones out here, but you're going to need some space because it's kind of a big table. So I'll go ahead and put L4. That's fine. Click return. And voila, let's hit OK. And let's see what happens. But here comes our table, right? Now, with this nice little table, it gives you all kinds of statistical information about the test that you just ran. First, what you see is the mean, 4.675, 6.675. And you see that matches exactly like it was down here, right? This is the variance, which shows kind of the distribution of the data. And you can refer to some other YouTube videos on how to make sense of the data. But it's basically, is it very distributed or is everything spread out or is everything clustered around a couple of numbers? That's kind of what you're looking at there. We have the number of observations at 40. We've got our Pearson's coalition, degrees of freedom, a number of other different pieces here. What I want to draw your attention to really is these ones down here. There's the one-tailed and two-tailed t-test, right? Now, most of these times you're going to use the two-tailed t-test. You can use a one-tailed in particular circumstances, but I think just sticking with the two-tailed test, rather than getting the differences between the two, just stick with the two-tailed. It's a little bit more conservative anyways. So let's go ahead and click on this. And what you see here is we have a big number here in what looks to me like scientific notation. So it's 2.95 times e to the 18th, right? That is a very, very, very small number. But if you're not sure how to interpret scientific notation, you can always go back to home and click over here where it says general and change this to a number. And then open up the number of decimal points a little bit here and see kind of where we're at. And you'll see this number is so small. Look at this. It's so small that it's got just zeros and zeros and zeros. How many zeros do we have to go? Probably 18 before we see a number. Oh, there it is. There's a 32965, right? So that gives you a sense of just how small this number is. Now, remember, when we're looking at p-values, what we're looking for is this number lower than 0.05? And the answer is absolutely it's lower than 0.05. I'll go ahead and highlight it so you can see it. definitely lower than 0.05. So we can conclude that well, let's say here, what we'd say is that the difference in these two means is very likely, certainly observed, the post score was higher. But when we think about generalizing that to a population represented by these data, we can say, yeah, pretty much 99 times out of 100, when you run this program with this group of people, you're going to get this kind of a difference. More than 99 times out of 100. It's actually like 99.9999 times out of you're going to get it that way. So that's basically what we can interpret here. So what we would say here is, yes, these are differences here. And what we're saying here is effectively that the program is showing some evidence that, we are seeing changes between the pre and the post score. Now, again, you are all strong researchers and there wasn't a control group here. So we don't know if that was due just to the program or due to some external factor. But what we can say is there is a statistically significant difference, which shows some positive evidence to suggest that, we may be seeing some improvement in the participants in this program as they progress through the program. So this would be very promising data if you were doing some evaluation work on it. Now, let's take a look at another very useful test. And you might say to yourself, hey, what we want to look at is what are the differences? Do the differences in these scores depend on, the differences in, say, satisfaction scores depend on, for example, the type of service that person received? That would be interesting to find out, right? Maybe the satisfaction varies based on services received. Now, we've done that a little bit with gender, but here's a good way to do it with more than one group. You can do this very effectively with this Anova. And the difference here is when we did it with a chi-square in the other example of the video, what we were doing is we were comparing satisfied yes or no, basically a binary outcome. What we can do here is actually look at examining the means. So we're actually not looking at yes, no, we're looking at what's the actual mean score on satisfaction based on services received. Now let's go ahead and take a look. We'll go ahead here and click on we'll go to data again, and then we'll click on data analysis. And this time I'm going to scroll on up here and we're going to click on Anova single factor. Excellent. Now, in Anova single factor, oh, wait a minute, I forgot a step. Cancel. Before we get ahead of ourselves here, the data are structured in a way that makes it a little bit more difficult for us to be able to interpret it for the purposes of Anova. So first thing I'm going to do is I'm going to move this t-test way out of the way over here. Store that over there. Copy, paste. Then what I'm going to do here is take the entire table here. I'm going to highlight it. And what I'm going to do is I'm going to sort the data. And what I have to do is put these in columns, and I'll show you what I mean in just a section. We're going to sort by the column services received, A to Z, and click OK. And that helps us see we have all our housing support together, all our job training, mental health, substance use, etc. Now, when you're doing an Anova in Excel, it's helpful to have the data set up where the 4 categories are set up like this, which is called wide format if you're ever doing data analysis work. Sorry, here. Or versus long, which is what it's currently in. So I've got housing here, so I'm going to take all my housing satisfaction scores. I'm going to copy those, right? And I'm going to copy all my job training ones, copy those, put those in here. I'm going to take all my mental health in here, copy that there. And then I'm going to take all my substance use ones, copy those. It's nice that they all kind of match up and you need the same amount for each person. So it makes it a little bit easier for our analysis. Now my data are set up for doing an Anova. So I'm going to highlight all of these here. Click on data analysis. And then I'm going to go down, to Anova single factors right there at the top. Click OK. I've got my input range. I've already highlighted M1 through P10. So that's, or P11. So that's already set up. But you could always click on this and just re-highlight it again if you needed to do that. And then click return. Voila. It's grouped by columns here, right, versus rows. And then we do have labels in the first row. So we're going to leave those labels there. Alpha 0.05 is good. Our output range, let's go ahead and put our output range and identify that at M15. That sounds good. We're going to have a nice big table again. And then we'll click OK. And you'll see that you have another table just like we did with the t-test. And you've got our different groups here. We've got how many are in them, 10. We've got the average score, 3.9, 3.8, 3.9, and our variances. And you'll see that the averages really don't change very much, 3.8, 3.9. There's not a huge difference between these different groups. And when you look down here at our Anova, we've got these degrees of freedom, these F value, all these different statistical points here. And again, if you would like to learn more, go check out a statistics book so you can really interpret all that information, which I think would be a great idea for you. But for the purposes of this class, I want you to look at the p-value. And here we see a big difference in the p-value between what we saw last time and here. This we see 0.99. I remember over here, it was 0.0. So this was almost 0, and this is a p-value of almost 1. Well, a p-value of almost 1 is much higher than 0.05. So what we see is this p-value is suggesting that there is no statistically significant difference in the satisfaction scores based on the services received. So I guess maybe what you could conclude is that, well, it doesn't really matter what service program you go into, you're going to have the same level of satisfaction, which I guess maybe from an equity perspective might be a good thing. Maybe we would take some good source or information from that as a person who's evaluating this program. So anyways, that is how you approach both the t-test and the Anova in Excel and using the stats package that we have here. Now, I would love to give another example that we can use here. And what I've done is I've actually already deleted the data here across our Anova. I want to give an example of Anova not looking at satisfaction, but actually looking at post scores. And what we can do is to see, hey, is the post score different across each of these three groups? It would be interesting to see. So what you can do here, we've already got the data sorted, so we can take the post score data this time instead of the satisfaction data. We'll take housing support here. We'll take job training. Voila. We'll take mental health. Copy that over. And then we'll take substance use. Right. Now that's all set up there. We'll go ahead and highlight it just like we did before. We're going to click on data analysis. You guys are getting the hang of this, right? The t-test and the Anova, it's all the same process. You just got to highlight the data and then click on the test and you're going to get it. So we'll go click on Anova single factor. Voila. We'll say okay. Thankfully, because I've already highlighted it, the data already there, group by columns. We're going to check labels in the first row. We're going to put our output range a little bit lower here because we don't want to interfere with our existing table. I'm going to click on this one right here, and then I'm going to click enter. And then I'll go ahead and click OK. And what do we get? Well, here's our Anova down here. Now, here we have something very interesting. Our housing, we had 10 people in each of the different groups, 10 scores. And the average score for the post score for housing support was 5.9. The average score for job training was 6.9. Mental health, 6.3. Substance use, 7.6. Now, we observe a difference here. Certainly 7.6 is higher than 5.9. But the question is that difference statistically significant? And this Anova is going to help us answer that question. Now, again, we come down here, a bunch of stats lines, but I want to just draw your attention to the p-value. And I'll go ahead and highlight it so you can take a look. What we see is that the p-value is 0.067. And in the world of statistics, we would interpret that as that there is not a statistically significant difference between these groups as observed. However, many of these statistical tests are influenced by sample size. And so if we had had a larger sample, we may have gotten a slightly different result, even with similar means. And so what we might conclude from this is that it's not statistically significant, but 0.06 is very close to 0.05. And so maybe with more data collection, we would see an observed difference with a higher sample size. So for now, we can't conclude that there's a difference in the post score based on these different groups, but it would be something we'd want to pay attention to as evaluators, to be thinking about, hey, what could be going on here? And maybe as we do further data collection, we may start to see a statistically significant difference. In any case, I hope this is helpful for you as you are thinking about how to use t-tests and Anovas in your evaluation work. Thank you so much for joining and listening today.